Hello, everybody. This is Chris Rickey. Thank you for joining today's webinar, where I'm going to be giving an overview and demonstration of Prometheus. As mentioned, my name is Chris Rickey, and I'm a solutions engineer here at CoreOS. Before I jump into it, as always, if you guys have any questions about anything that I'm covering today, you can ask your question in the Bright Talk chat, and at the end, we'll go through and answer some of those questions for you. In terms of our agenda today, what we're going to cover, I want to take a few minutes and just level set and talk about some of the challenges that we see a lot of organizations face as they embark on this distributed systems and microservices oriented architecture. I'll then get into a little more specifics of Prometheus, an overview of Prometheus and how it kind of fits in solving some of those problems, and then dive into some topics like what is time series data, what are some of the metrics that Prometheus helps me capture, how does alerting work, and I'll give a demonstration of Prometheus in action. So distributed systems and microservices, containers, they're all the rage today, and for good reason. They offer a tremendous amount of benefits to organizations and their applications. So for instance, with a distributed system, my applications are more resilient to failures. I can scale my systems more effectively. You know, with a monolithic application, if I want to scale the thing, I've got to scale the entire monolith. And in some cases, that's not even possible. With microservices, I can scale parts of my system because I have a lot more flexibility. My teams that are working on these systems are often more autonomous, and because the system's more loosely coupled, the different components can change more freely, and this enables things like more agility, and I can get changes out more frequently and faster to my end users. But with all of these benefits, there's also challenges that organizations have to consider before they start going down in these projects. So because of our systems are distributed, there's a lot more moving parts, which means there's more places for failure. And it's also oftentimes harder to troubleshoot where those failures occur. And as I'm an operator and I'm trying to troubleshoot a system, one of the things that I rely on really heavily is logs. And with a distributed system, logging becomes a new challenge. So with a distributed system, it's much more dynamic. So I have components and containers that are spinning up and down, and oftentimes if I'm trying to go in after the fact and look up logs, the container that where the problem was occurring might not even be there anymore. So the logs might not even be there anymore. So we want to take account for how we're going to handle and consolidate and aggregate all of those logs so that we can troubleshoot more effectively. Our systems that are distributed are also they're more sensitive to networking issues, right? So if there's any networking latency, that could have a significant effect on our applications. And the other challenge that we often see is more cultural. Because our systems are composed of all these different components that have to talk to each other, when I make a request to a service, that might call 4 or 5 other services downstream that might be maintained by different teams. And if there's a problem and we're not sure where the problem resides, then it results in a lot of finger pointing. So, so again, these are some of the challenges that we see, and systems ability, or our ability to be able to easily understand what's going on within the system, is something we refer to as observability. So observability is again, you know, how easy is it for me to understand what's happening inside of this distributed application. And if I have good observability, then it allows me to be more proactive, for one. And so understanding issues before they start permeating and becoming bigger problems, I can resolve issues a lot faster. And with observability, as an operator, what it does is it gives me more confidence, and as it gives development organizations more confidence, because if I'm trying to deliver change rapidly, I want to have confidence that if there is a problem, I can understand what that problem is quickly and resolve that problem quickly. And so the more confidence I have, the faster I can deliver, the faster I can get value out to my end users. And of course, right, if I'm getting change out faster and getting value out faster, if I'm solving problems faster, then it's going to improve the overall satisfaction for my customers. So observability is really important. How we gain better observability into a system is we need new tools. So a lot of customers that I work with, that they're coming from existing monolithic systems, and they're starting to decompose them into microservices. And when we start getting into how they're doing things today, what tools they're using today, what are you using for monitoring, they're using a lot of systems that were built to help support their existing monolithic application. And so they'll ask, well, I already have a monitoring tool. How's that going to work, with Kubernetes, for instance? But the reality is, a lot of these problems require new tools. And so there's three key areas that we focus on to gain better observability of our systems. One is tracing. So I talked about how our applications are now composed of multiple services, and as a request comes in, it might hit several of those services. And so traceability helps me understand the path that request takes throughout my system. And of course helps me understand, when there is a problem, I can pinpoint it a lot quicker. It helps solve some of those finger pointing problems. There's tools out there, some open source tools out there. A popular one that we hear about is Zipkin, but there's others as well. Of course, monitoring, which we're going to get into more detail today, is another really important part of observability. So that's monitoring helps us understand the health and the status of our systems. And Prometheus, which will, of course, is the purpose of this webinar, but we'll dive into more deeply, is a really popular tool that's used for monitoring distributed systems. And then the logging problem. How do we aggregate all those logs? You may have heard of the ELK stack. What we do with logging is we deploy an agent to all of our nodes, which are collecting up all of the logs and shipping them to a centralized server. So we use FluentD at CoreOS with our platform Tectonic, and then we can ship them to different destinations like Elastic so they can do log analysis. So for monitoring, there's really two types of monitoring that we're looking at. So first type is infrastructure. And so this is where we want to understand the disk utilization, the CPU utilization, the memory consumption across our system. And I can use this information to make decisions about how I want to scale my cluster. Maybe I have a new workload that I need to onboard into my Kubernetes cluster, and I want to ensure that I have enough capacity to support that particular workload. And so with infrastructure monitoring, I get that level of visibility. The other side is application performance monitoring. So understanding the health and status of the apps that my development teams are deploying and running within the cluster. And so this is where I want to understand if there are any performance problems around latency. I might want to understand the total number of requests that those services are serving, and then I can analyze it in different ways and understand, when am I seeing peaks in traffic, what times of day, et cetera. And then error rates, right? If my services are returning errors, then I want to be able to understand that and analyze it. So Prometheus is an open source monitoring tool that helps me with both of those things, infrastructure monitoring as well as application performance monitoring. If you're familiar with Kubernetes and its history, Kubernetes was inspired by a Google project called Borg. And Prometheus, so Borg had a monitoring system built around it called Borg-Mon. So Prometheus was actually inspired by Borg-Mon. So needless to say, Prometheus works really, really well with a highly dynamic distributed architecture like Kubernetes. And it's like I said, it's open source. It's very popular on GitHub. There's a strong community behind it. And I mentioned those three things that are key for observability. Prometheus is really focused on the metrics part of it, right? It's not used for logging. It's not for tracing. So the architecture of Prometheus, we have the Prometheus server, And with Prometheus server, we're also storing all of the time series data, which we'll talk about. And what Prometheus is doing is it's scraping targets, it's scraping endpoints for these metrics. So the way we get metrics to Prometheus is really one of three ways. So in many custom applications, development teams are instrumenting their applications with client libraries that provide that are serving up metrics on a port for Prometheus to scrape. And so Prometheus on a certain interval will scrape those metrics from your targets that you've deployed. For some workloads though, and maybe they're cron jobs, things that are shorter lived, they might go up and down, run and do their thing quicker than Prometheus has a chance to scrape. And so for those types of use cases, those applications will push metrics to what we call a push gateway, and then Prometheus scrapes those metrics from a push gateway. For other types of systems and more off-the-shelf type systems, there are exporters that have been developed that you can deploy alongside your applications, and those exporters will serve the metrics to Prometheus. And so essentially, Prometheus will scrape those exporters. So we use exporters to get node level metrics, for instance. So we deploy a node exporter to all of our nodes in a cluster, and it's serving up the metrics around the CPU and networking and in disk, et cetera, to our cluster. Prometheus leverages service discovery to actually find its target that it needs to scrape. So this is why it works really well with Kubernetes, because with Kubernetes, as we're deploying pods, they're popping up on different nodes, or we might have auto-scaling rules in place that are scaling our workloads up and down. So it's very dynamic. And through Kubernetes service discovery, Prometheus is able to find those new workloads automatically and start collecting the metrics for them. We also leverage a component called Alert Manager. So Alert Manager is where we can define rules for when we want to be notified of certain events. I'll talk about that more later, but as we find these alerts, we can then send out notifications to through different mechanisms. So you might use PagerDuty today. Maybe it's email notifications. Maybe it's Slack. A lot of our customers have Slack channels where when there are issues that occur, it'll send a message to their Slack channel for them. And so this is what, again, helps them become more proactive as problems are occurring. And then there's some UIs that we have to actually work with Prometheus. So there's a Prometheus UI, and then a lot of customers will also use Grafana for more dashboarding type of capabilities. So collecting metrics, I actually touched on this a little bit before, but essentially your applications that you're monitoring, they'll serve the metrics up on some endpoint. It's typically /metrics. And then using service discovery, or in some cases you can use static configuration as well, it'll discover those endpoints and start collecting the metrics. And for some use cases, you may be using push gateways. But for a lot of different programming languages, there's client libraries out there that allow you to instrument your applications. And there's positives and negatives of using application instrumentation. The benefit is that it gives you a lot of control, and so you can really control the types of metrics that you're serving. On the downside, if you want to make a change to your instrumentation, it's a code change, right? And so it has to go through the life cycle. So there is a bit of a trade-off there. So as I was learning about Prometheus, one of the first things that I was trying to just wrap my head around is, what is time series data? So Prometheus is, you'll hear it referred to as a time series database. And essentially what that means is it's plotting data along a time-ordered sequence. And an example that I like to use, sort of like a normal everyday scenario, is let's say you're standing beside a busy road and you're counting cars. And every second, you're counting the total number of cars. And with every second that passes, that total number of cars increments. Right? This is an example of a counter metric, where it continually goes up every second as a car passes, as you count cars. And so an example in the application world of a counter would be the total number of requests. Every request that hits that application, that number is going to increment. So that's one type of metric, is a counter. I'll talk a little bit more about some other types of metrics in a minute. But the other thing that Prometheus does with its time series database is it applies labels. And so through labels, it gives us another dimension to our data model. So it makes our data model multi-dimensional. And so, for example, with our car scenario, I might also be tracking the color of the car or the make and model of the car. So now I can run finer-tuned queries to say, show me how many white cars passed, or how many Fords that are red passed. In the application world, that might be the total number of post requests, or the total number of gets, the total number of get requests that returned in a 404. So I can use these labels to further slice and dice my metrics, which is really helpful, especially when you're trying to analyze and understand what's going on in these complex systems. So I mentioned there's a few other metric types as well. There's gauges, there's histograms, and there's summaries. So where a counter always increases, and it continues to increase for the life of that particular application, it's really useful for counting the number of requests, the number of errors, et cetera. A gauge, on the other hand, can go up or down, right? So gauges are typically used to measure things like memory utilization or CPU utilization, because you might go from 80% capacity down to 50% capacity, back up to 90% capacity. So that understanding that is where we would use something like a gauge. Histograms and summaries, they're very similar to each other. Basically, what histogram and summary allow us to do is they capture the total number of observations as well as the total sum of all observations. So having the two of these buckets together allows us to do things like calculate averages. So this example here that you see on the screen, this is an example query that allows me to understand the average response time for a particular API. Right? And so what it's doing is it's grabbing a 5-minute sample of our time series and dividing the total sum of the request response times by the total count of the requests within that 5-minute span to return in an average for us. So that's metrics in a nutshell. For querying, we leverage an expression language called PromQL. And so PromQL is really powerful. Getting into the specifics and all the details of PromQL is a little bit outside the scope of this particular webinar. But if you go to the Prometheus blog, there's some great examples of PromQL and how it all works. But PromQL provides lots of different functions that you can use to aggregate your time series data. You can use PromQL to create graphs, or you could also use view it in tabular form. And like I mentioned, it's pretty powerful, so it supports different operators as you would expect. You can use regular expressions. So in this case, this is giving us the total requests, total requests that are not get requests in our environments, in our staging, testing, or development environments. Right. That's just an example of some of the things that you can do with PromQL. To visualize, Prometheus has a built-in dashboard, or not a dashboard, but a built-in web interface. This allows us to do more ad hoc querying. But if I wanted these charts to persist, and I wanted to do more dashboarding, Grafana is probably the most popular dashboarding tool that's used along with Prometheus. And there's a bunch of pre-built templates out there in the community that allow you to get started really quickly to some common dashboards that pull different metrics, commonly used metrics for Prometheus. And then I talked about Alert Manager already, but some of the other things that Alert Manager allows us to do is it has some capabilities around grouping. So if you do have a service that is failing and in a complex environment, that could result in a lot of cascading failure, so other services start to fail. And Prometheus, or an Alert Manager, has the ability to group those alerts together into a single alert, so you're not getting blasted with thousands of different alerts that are all resulting from sort of the same cause. The other thing we can do is deduplication. So Alert Manager can be configured in a highly available. So you have multiple Alert Managers, and they actually coordinate across each other. So using the gossip protocol, they're communicating. So when an alert's being sent, it's only getting sent through one Alert Manager versus getting duplicate alerts from multiple Alert Managers if you have HA configured. So we use Prometheus and Alert Manager pretty heavily within our enterprise Kubernetes distribution called Tectonic. Tectonic is our enterprise distribution that has fully automated operations for supporting your Kubernetes clusters. So we stay very close to upstream Kubernetes. When there's new releases of Kubernetes available, we then push out a new version of Tectonic to our customers, which allows them with a single click of a button to upgrade their entire stack. And that includes all of the core Kubernetes components, the Docker engine, the container Linux operating system that the cluster is running on. And then we have built-in capability, out-of-the-box capabilities around security. So Kubernetes upstream doesn't provide a lot of security in terms of authentication and authorization. So we have the ability to connect directly to your identity provider, configure things like single sign-on, and then we have a management console on top of it where we can manage our clusters and across clusters even. So if you have lots of clusters in your environment, with Tectonic you can do multi-cluster management. And we build Prometheus into the cluster so that it's out of the box monitoring the health and status of Kubernetes and the nodes, the infrastructure underneath it. But we also provide services that make it easy for development teams to spin up their own instances of Prometheus, and I'll actually show this, where if you want to instrument your own application and have Prometheus monitoring it, you can use our Open Cloud services. So an Open Cloud service is similar to a cloud service, a proprietary cloud service that you might provision, say, through AWS or Azure, where it's highly available, it's automatically managed. So in these new versions, the Open Cloud services upgrade automatically. They're secure, but they can run anywhere. So our services will run anywhere that Tectonic is running, whether it's on-prem, in Azure, in AWS, on VMware, et cetera. So it frees you from the underlying clouds. You're not locked in. They can also be run offline, and they're container native. So Prometheus is an example of one of those, and we have 3 other out-of-the-box Open Cloud services that we provide with Tectonic. We have Vault if you need to do secrets management in a highly available way. You can use our Vault operator. We also have etcd if you wanted to leverage etcd with your own applications for doing things like distributed keys within your application, and then of course Prometheus. So with Prometheus, what we can do with an Open Cloud service is, with just a few clicks, provision a new instance of Prometheus that we can then integrate with our applications that we have running within the cluster. They're highly available. When Tectonic upgrades and there's a new version of Prometheus, we'll automatically update these instances of Prometheus for you. It's built all on open source technology, and it's fully supported by CoreOS. And it really lowers the cost of ownership of running something like Prometheus and Kubernetes in your environment and at scale. All right, so let's jump into a quick demo. So I mentioned that with Prometheus, there's really 2 sides of the monitoring that we're focused on: infrastructure monitoring and application monitoring. So I'm going to show both. So I'm going to start out with the infrastructure side of it. So what we're looking at here is Tectonic, our Kubernetes, and through our dashboard we start to surface some of these Prometheus metrics for you. But we also have the ability to launch directly into Prometheus to get to do more of the querying and understanding the alerts and what's going on. So let me log in here. And we automatically secure Prometheus through our identity management solution. So in Prometheus, if I go to my targets, you can see that it's monitoring all of the control plane components of my cluster. And we have pre-configured alerts out of the box that will get notified if problems start occurring, like if we start running out of disk space, if we start running low on memory, these alerts will start firing and notify us, and then we can tie these to our alerting system, again, whether it's email notification or Slack or whatever the system of choice is. And we have a bunch of metrics out of the box that you can run to do more further grained diagnostics. So for instance, if I want to look at the instance CPU rate, I can execute this metric and I'll get a chart for the instance CPU utilization across all of my nodes. What we also bundle with Tectonic is Grafana. So I mentioned Grafana being a powerful dashboarding tool for understanding, or for dashboarding and viewing all of these metrics. So this is an example of a capacity planning dashboard, so we can understand the health and status of the cluster and the CPU utilization again. And so I might use a dashboard like this if I am onboarding a new team. I'll look at this and understand if I have the capacity to bring it on, and this is where I might make a scaling decision, right? I could then use Terraform, for instance, to scale my Tectonic cluster, or maybe I have a cluster autoscaler in place and it'll automatically scale. But this dashboard will give me that insight. That's the infrastructure side of it that we do out of the box. If we want, as a development team now, I have an application that I've deployed into this cluster. It's a really simple Python API. If I go to my deployments, you can see I've got a Hello World deployment here. It's running 3 pods, and through my command line interface, I'm actually just hitting it in a loop, so you can see it's hitting it, it's returning pretty quickly. But what I want to do is configure Prometheus to actually monitor this API. And let me just show you real quick. If I go to the service itself, I'll show you where it's hitting. It's serving up the metrics on port 8000. So you can see this API is serving. It's instrumented, so it's serving up these metrics for me. It's returning the latency. For instance, it's also got a counter in place where it's tracking the total number of requests. So now let me go ahead and provision through our open cloud services an instance of Prometheus here. So if I go into Prometheus, I don't have any instances running yet. The first thing I want to do is provision a service monitor. So what a service monitor does is it selects the service that it's going to start scraping. So what I'm going to do is configure this service monitor to connect to that API that I was just running. So I'm just going to fill out a couple fields. The way it does that is through labels and selectors. So I have a label on my application called Run Hello World. And this is in my monitoring demo namespace. And the endpoint that I want it to scrape is called metrics. It's my metrics endpoint. And by default, it just scrapes that metric every 30 seconds. For the purpose of the demo, I'm just going to bump this down, just do it every 5 seconds. And I'll hit create. So I have a service monitor that's scraping that endpoint. I'm going to provision an instance of Prometheus that will use that service monitor. So to do that, actually before I do that, similar to how the service monitor selects the application or the service through labels, Prometheus selects the service monitor through labels. So I'm going to actually add a new label to this. I'm just going to call it Hello World. And now when I create my Prometheus, I can say select service monitors where Hello World exists. I also have a rules file. So a rules file is where I define my alerting rules. And this is saved as a config map that I've already deployed, or I've already uploaded into this cluster. And I just have a different label on it called Hello World for consistency. So it's going to find the rule that has Prometheus equals Hello World, and I can hit create. So this is spinning up now. If I go to my resources, it's deploying it as a stateful set, and it provisioned 2 pods for me. So this is the sort of the magic of the Open Cloud service, is it took care of provisioning, a highly available Prometheus instance for me. It took care of configuring the stateful set for me, and with just a few configurations, I basically pointed it to the application that I wanted to monitor. I now have a service that is exposing my Prometheus dashboard, or my Prometheus instance. So if I go back to here, I'm just going to do a refresh. And now we can see my Prometheus is now up and running. If I go to my targets, you can see it's scraping my 3 Hello World pods that I was showing previously. And let me just, to demonstrate some of the service discovery, I mentioned how these are dynamic environments. So while now I have 3 pods, let's say I scale this thing up to 6 pods. So Kubernetes is doing a scaling for us. And if I go back to Prometheus and do a refresh, you can see it automatically discovered those 3 new pods for me. So I didn't have to worry about making any changes to my Prometheus configuration as my application scales. And then I've also created, through that config map that I mentioned, an alert where it is checking the response time for that API. And so what this is doing is, if the response time is greater than 1 second, I want to create an alert. And so right now I don't have any alerts because my API is responding pretty quickly. So let me go ahead and make a change here and see if I can trigger this alert. So I'm going to go to my manifest for this deployment, for this application, and I'm going to change this to my slow version. And in just a second, we'll start to see as that change rolls out. Now it's returning. You can see every response now returning the slow version, and this is basically introducing some latency here. So if I let this run for a few seconds, we'll see it trigger an alert. So let's see if it's triggered it yet. So it usually takes about 30 seconds or so. So that's running. The other thing I'll show is some of the querying. So if I wanted to create a quick chart on the request count, I can use the built-in metric here, and you can see it's breaking it down by the pod, the replica. So we can kind of monitor. This is something we can plug onto a dashboard as well. Let's go back to our pod. So my alert's now fired. Again, presumably I would be notified of this. This is useful for, I can do things like canary deployments as well. So I might have a canary that I've done my deployment to, and then I can understand if it's my canary that's responding slow versus my production replicas, and use different techniques to do advanced deployments and really, again, build confidence in how I'm deploying my changes. So that's what I wanted to show for a demo. I'm going to go back to the slides here and check for any questions. Okay, are slides available? So I've got 2 questions asking if slides are available. I think we can upload the slides. Amanda, I'm assuming that's a capability within BrightTalk here?
Yes, I can upload the slides after the presentation is over, and they will be sent to anybody that is attending.
Awesome, okay. So we will make sure that happens. And what version of Prometheus is used with the Open Cloud Service? So that's a good question. I mentioned how where with Tectonic, we're monitoring the infrastructure as well as the applications through OCS. The infrastructure monitoring is right now is using Prometheus 2.0. In our next release, we're going to be rolling out Prometheus 2.0 for the Open Cloud Service. So the application monitoring side of it will be updated to 2.0 in our next release. And through, again, our automated operations, we'll have the built-in logic to actually upgrade your Prometheus instances that you may be leveraging. So that's what I had to share. I want to thank everybody for joining us today. And if you have any further questions, you can feel free to reach out to info@coreos.com. Thank you.